Now it is physics class number 1, constant velocity motion. Now, firstly, we look to constant velocity, and that's that final velocity equals to initial velocity. So, looking at momentum principle, we see that delta p is net force times the delta time, and looking at it, we see that the mass times the final velocity equals to the mass times the initial velocity plus net force times delta t. So now we divide by mass, and we see that if we want final velocity equals to initial velocity, we may have the net force equal to 0, and that's what we have assumed for our model. Now in our case, we see that the average velocity is delta x divided by delta t, and the result here is 1.15 meters divided by second. But in our case, the ball also moves through the y-axis. So if we do the same, the average velocity equals to delta y divided by delta t. We got that it is 0.09 meters divided by second. So the vector will be like that, like this. Now if we look at our tracker modeling, we see that here is me throwing the ball. The ball here has a mass of 0.306, and now we have look at the measure, the diameter of the ball in that case, which is approximately 20 centimeters, so 0.2 meters, and the axis, which here is my positive x direction and my y positive direction. And now if we look at it, we saw that the ball also moves a little bit to the y direction. And now we can look at our model for see how it may be, if also is correct, if all the things are correct. So now that's also the x positive direction and y positive direction. If we change the axis, it won't be the same that on our experiment. And here we've got ball mass, the ball initial position, and the velocity ball vector. Now we see that while t is less than 0.76, and at the net force we have assumed that it's 0. So now if we analyze that, we'll see that our experimental x values, given in blue in that case, are a little bit different from our theoretical x, given here in pink. So now we can say, what? Why is it? And on our theoretical x, we have now assumed that there are no forces acting on the system, the ball in our case. But on real world, on the system, the ball has interaction with the surroundings, the ground, the air, everything around it. And for example, the deceleration here may be caused by friction, and the movement in the y-axis will be because of the initial force that I give to the ball for that it moves. So now we can say, well, but what if we change the force? If we have our system with some force, it will be a parabolical graph result. So that's different of we want. And that's all, our number 1 constant velocity motion.